Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structures. Both structures are trimethylcyclopentane rings with 3 methyl substituents. We need to assign the configurations at each stereocenter and compare the two molecules. Moving on to the next step. Analyze the left structure. The cyclopentane has methyl groups at 3 positions. Reading the stereocenters, the top carbon has a methyl on a wedge coming toward viewer, the bottom left carbon has a methyl on a dash going away, and the bottom right carbon has a methyl on a wedge coming toward viewer. This gives a specific set of RS configurations at each stereocenter. Moving on to the next step. Analyze the right structure. The cyclopentane has methyl groups at 3 positions as well. The top carbon has a methyl on a dash going away, the right carbon has a methyl on a wedge coming toward viewer, and the bottom right carbon has a methyl on a wedge coming toward viewer. This gives configurations that are the mirror image of the left structure at each stereocenter. And for the final step, compare the two structures. When we compare the configurations at each stereocenter systematically, every stereocenter in the right structure has the opposite configuration to the corresponding stereocenter in the left structure. This means the two structures are non-superimposable mirror images of each other. Define the relationship. Two molecules that are non-superimposable mirror images of each other with the same connectivity, constitutional structure, are enantiomers. They are not identical, would require superimposability, not diastereomers, which would require some but not all stereocenters to be inverted, and thus none of the above is also incorrect. Eliminate other options. A. Identical, ruled out because the molecules are mirror images and non-superimposable. B. Diastereomers, ruled out because all stereocenters are inverted, not just some. D. None of the above, ruled out because enantiomers is a valid and accurate description. Therefore, the correct answer is C. Therefore, the correct answer is option C.